What is pressure altitude? So this is your airport. This is your mean sea level where QNH is 1025 and elevation is measured from mean sea level. So elevation is equal to 4000. Now pressure altitude is always measured from standard pressure setting 1013. So 1013 being less than 1025, it's the level, that level will be above 1025, because when we go to higher and higher altitudes, pressure decreases. So let's draw this 1013 pressure level here. Okay. Now pressure altitude will be measured from standard pressure setting datum. So now this pressure altitude, as you can see, is your elevation minus the height difference between these two pressure levels. Elevation is 4000. Height difference between these two pressure levels is what? The pressure difference is 12 millibars. So height difference will be equal to 12 into 27, that is 324 or approximately 320 feet, right? So pressure altitude is nothing but this big height minus this height difference. Substitute the values. 4000 minus 320, pressure altitude will be 3680. Okay, so select a value which is close to this answer, 3700 something. If pressure increases while temperature increases in the ISA, they are talking about ISA. Now what happens? What happens to density? Now density is controlled by three factors. Density is controlled by three factors. The number one factor is temperature. Second, humidity. The third is pressure. Temperature, humidity, pressure. Now increase in temperature will cause a decrease in density. The air becomes thinner, so density decreases. Temperature decreases. If temperature becomes cold, density of air will increase. Pressure. If pressure increases, density will increase. Pressure decreases, density will decrease. Humidity. If air is humid, the density of air will be less. If air is dry, the density of air will be better, more. Air will be denser, more denser. So now here pressure increases and temperature increases. Now if pressure increases, density increases. If temperature increases, density decreases. So to contradict things. So what is the final result? Remember, out of pressure and temperature, pressure is the dominating factor. Pressure is the dominating factor. So the end result will be density will, if pressure increases, density will increase. Option A. Okay, in ISA, definitely density will increase. Now, if in a non-ISA, same question but in non-ISA conditions, density might increase or decrease depending whether depending on whether the lapse rate depending on the lapse rates of pressure depending on the lapse rates of pressure and temperature depending on the lapse rates of pressure and temperature. Now, if the lapse rate of temperature is more than the lapse rate of pressure, so temperature will be the controlling factor. If pressure lapse rate is more than temperature lapse rate, so pressure will be the controlling factor. So density might increase or decrease, but we cannot say it with certainty in case of non-standard atmosphere. In ISA atmosphere, yes, density will definitely increase because pressure is the dominating factor. Next, 54. If pressure remains constant as temperature increases, so pressure is constant, so ignore that. Temperature increases, what will happen? Density will decrease. Density will decrease. So, Charlie or delta. What will happen to the ratio between calibrated airspeed and true airspeed? Now, pressure is constant. Calibrated airspeed depends on your uh, pressure. So nothing will happen to calibrated airspeed, but what will happen to true airspeed? Now true airspeed, remember this, is always more in warm air than cold air, meaning in less dense condition compared to more dense condition. Okay, so the ratio, so if density will decrease, true airspeed will increase, right? So calibrated airspeed is going to remain constant, let's say 200 knots, and task is going to increase. So let's say initially task 1 is temperature was cold, task 1 is 70 knots, and when temperature becomes warmer, task will increase to 100 knots. So initially the ratio will be cas by tas, so 200 by 70, that is equal to 2.85, so approximately 3. And second cas by tas, second scenario when tas increases, 200 by 100, which is equal to 2. So the ratio has decreased from 3 to a new value of 2. So the correct answer will be density will decrease, yes, causing the calibrated airspeed to true airspeed ratio to decrease. Now density altitude is what? Density altitude is nothing but pressure altitude corrected for non-standard temperature, meaning ISA deviation. Right? So the elevation at which the prevailing density occurs in the ISA, the pressure altitude at which the prevailing temperature occurs in the ISA, the pressure altitude at which the prevailing density occurs in ISA. So it can be pressure, altitude, and elevation. Now, if your airport is located at mean sea level, or if your airport in ISA conditions, so in that case, elevation can be regarded as pressure altitude because it's coinciding with the standard pressure setting 1013. So that's why statements 1 and 3 are the right ones. 56. As altitude increases in the ISA, okay, pressure will decrease, temperature will also decrease, but pressure will be the dominant factor, will be the controlling factor, like I said before, mentioned before, over density. So the effects of decreasing pressure outweigh those of decreasing temperature, yes. So aircraft performance decreases, yes. So option A is right. If pressure decreases, density will decrease. Density of air will it will decrease. So the aircraft performance will also decrease. Effects of decreasing temperature outweigh pressure? No. Effects of decreasing density outweigh pressure? No. Effects of increasing task to cash ratio outweigh those of pressure? No. So option A is the right one. What is density altitude? Altitude at which prevailing conditions could occur in the ISA. So prevailing conditions, the prevailing conditions, so they are not specific whether they are talking about density, pressure, temperature, humidity, anything else. Altitude at which prevailing density would occur in the ISA, yes. Altitude at which ISA conditions occur in the real atmosphere, no. Altitude found by dividing something, no. 58. If the temperature is 12 degrees Celsius, pressure altitude is 10,000, what is density altitude? So density altitude is pressure altitude plus 120 into ISA deviation. And some books they have written 118 in place of 120. It won't be much of a difference. So 10,000 plus 120 multiplied by ISA deviation. Now what is ISA deviation? ISA deviation is outside air temperature minus ISA. Outside air temperature is 12. ISA temperature at 10,000 feet will be equal to 15 minus 20, that is minus 5. 15 degrees Celsius minus 2 into pressure altitude. So minus of minus 5 plus 5, 17. That means outside temperature, the current outside temperature, ambient temperature is warmer than ISA by 17 degrees Celsius. So 10,000 plus 1040 is 12,040. Okay, so density altitude is 12,040. So altitude is 0 feet, you are at sea level. Ambient temperature is 10. What is density altitude? So pressure altitude plus 120 into ISA deviation. Now ISA temperature at mean sea level should be equal to, must be equal to 15. What is the outside temperature? It is 10. So temperature deviation is outside minus ambient minus 5 degrees Celsius, meaning outside temperature is colder than ISA by 5, minus 600. So density altitude is lower than pressure altitude, so better aircraft performance. Field elevation is 1000. Elevation is measured from QNH. QFE is 991. What is pressure altitude? Now pressure altitude is measured from standard pressure setting 1013.25. Or you can just consider 1013, that's fine. Now pressure altitude of the airport will be measured from 1013. So calculate the pressure difference between 1013 and 991.25 minus 991.67 is 21.58. So that translates into a height difference of, multiplied by 27, 582.66. So approximately pressure altitude will be 583 feet. Will be written as, or it will be mentioned as 580 feet. Okay. So this is how you do this question. This brings the curtains down on our video lecture. I hope you have understood all the questions that I have solved in this video lecture, the concept explanations. If you have any doubt, questions, feedback, let me know in the comment box of this video lecture. I hope you have learned something new today. Best of luck. Keep studying, keep working hard, be consistent, and don't forget to share this video lecture with your friends. Subscribe if you haven't yet, and hit the like button if you have liked this video lecture. Thank you for your time.